When it comes to making electronics projects and building up circuits, the most important thing you need is a decent amount of power to test them. So in my previous video, there I have shown why adapters cannot fulfill this need, and that's the time you need a variable bench power supply. But those can be literally expensive, and when you need the common 3.3 volts, 5 volts and 12 volts, there is a better option for you. And in this video I'm going to show you how you can build your own variable bench power supply using a old computer ATX power supply. This is a better option, and literally this can deliver more power, and this is cheap, and this is easy to make. So without this further ado, let's get started. And the first things first, and I'm gonna tell you what are the things you need to actually build this project. So the first is you will need a computer ATX power supply. You have your own choice. I have chosen a 250 watts computer ATX power supply. You will need some LEDs with 220 ohms current limiting resistors. You will need some big fat resistors as a load. You will be putting those as dummy load. I will be showing that in a minute. And the most important thing, one of the most important thing you need is the rotary switch with 6 positions, as you will switch 5 volts, 3.3 volts, 12 volts and negative 5 volts and negative 12 volts. So you will need 5 plus 1 that will be the off position. I will be discussing the working of rotary switch in a minute. You will need binding posts. I have used normal one for the output terminals. You will also need some binding post sort of thing for the output terminals. You will need some shrinking tubes or insulating tubes, Zener diode for required breakdown voltage, that will be 5 volts and 12 volts, tools as you are going to work on the aluminium which is there in the ATX power supply. You will need some metalworking tools. I suggest do not try it manually because that causes a little bit pain in the and there will be soldering works involved, so you will need a soldering iron or a soldering station and other tools for testing the final product. So the next things come is the making of the layout. I suggest first planning. I have planned the layout like this. There will be the rotary switch, and the below will be the 3 LEDs for our voltage indicator. That will be 3.3 volts, 5 volts and 12 volts, and in the up there will be the power indicators and the negative voltage level indicator and some other LEDs. You can plan your layout according to your choice. And I figured out a easier process of making it by using your Microsoft Word. First of all, you have to measure the size and dimensions of your components and then putting it onto Microsoft Word using the scale, and you can make the layout and print it out and cut it and paste it on your ATX power supply to use it as your guide for making the holes. And then one of the hardest things in this project, and I will say that the most hardest part in this project, is to drill the holes and to cut whatever you need to place on your ATX power supply. I have used some manual tools which just cause much more time to drill, and that is pretty much tough as I end up harming myself, cutting my fingers and all. So that is not recommended. If you have a automatic workshop kind of thing, then that is more easier for you to work in these projects. And then you have to place the components in their place. Now those are the things gone. And now I'm coming to the electronics part and mostly electrical part. First of all, you have to build a voltage indicator. As I have told you, you have to build a voltage indicator using 3 LEDs that will show you what the voltage output is. Is it 3.3 volts or is it 5 volts or is it 12 volts? So for that is very easy to build a normal voltage indicator, but as you are concerned with particular voltages, you will need some Zener diodes and place them in reverse bias so that the diode will need required breakdown voltage to actually pass the current through it. So I figured out 5 volts and 12 volts Zener diodes, and then place it according to this circuit diagram. You will need two voltage indicators, one for the positive voltage and one for the negative voltage. And in case of negative voltage, we have to place the same circuit but now using two LEDs, because we have minus 5 volts and minus 12 volts in our ATX power supply. So far so good. And now you have to open the power supply up, and this is the point I warn you, because do not act stupid, because this power supply contains high DC voltages and which can kill you. So you must be aware and do not act stupid. Do if you know what you're doing. So far so good. And now you have to cut the wires to a shorter length, and you have to figure out which wire is of what short. You can find that on the ATX power supply itself. Mine is something like this. I found find the output voltages and etc. from the wires, different wires. And now there are some important things. You have to short all same color wires but leaving some of them for the future. Something like you have to save some ground wires and some 5-volt wires for the main power indicators and all. You can figure out by yourself while doing the project. The gray wire in my case is used by the motherboard, so we don't need it. So we have to put it inside using tape or insulating tubes. You can also cut that out, just cut in short, just strip it and then just plate it or protect it with hot glue. But I am making sure that the wire is intact inside, so I am putting out sleevings and tapes to put it inside safely. And now one of the most important things, and you have to figure out in which rail the power is maximum. In my case, that is the 5-volt rail, as you can see, and you have to save one of those wires so that you have to put a dummy load in there to make the output stable while working with low powers. For that, you have to grab some big fat resistors of 5 watts. For 5 volt rail, use 5 ohms and 5 watt resistor, and that's my case. You may have your ATX power supply having the most power to its 12 volt rail, and then you have to use a 24 ohm and also 5 watt resistor. However, this is not included in the schematic, so be aware of that. The schematic you can find in the description. The most part is done now. I'm going to tell you working of the rotary switch. So the rotary switch described as the number of positions. As in this rotary switch I have 6 positions. Mine is a little bit bulky, a huge one rated 10 amps. You may not need that. You may use a small rotary switch for your purpose, as this is very tough to fit inside. So the working of the rotary switch is basically when you move the knob, it shorts the common terminal with one of those 6 terminals in there, and we will leave one of those 6 terminals as empty because we need that as off position. So the others will be 5 volts, 3.3 volts, 12 volts, negative 5 volts and negative 12 volts. So when you move the knob to the first position, that will short the common terminal with the 3.3 volts. When you move it one more towards right, that will short to the 5 volts with the common terminal, and like so it will act as a rotary switch. When you move, the voltage will increase or decrease according to your circuit. So now I have to connect all the shorted wires to the rotary switch terminals, excluding one that is going to be our off position, and connect the common terminal to the voltage level indicators, and finally the output to the header pin. And nearly done. So finish the project by connecting the green wire to the power switch and the other power wires to the LEDs, and now you are good to go. I shorted out this circuit diagram in Autodesk Eagle, link in the description. If you have any doubts, make connections according to the circuit diagram. So that's all for the circuit, and now it comes to the testing, and goodness me, when I switched on it for the first time, I heard a terrible noise coming out of it, and that is after digging a little bit, I found that is the coil whine, and there is hardly any solution in the internet to solve it. While digging a little bit more, I have seen some people say that you can eliminate the coil whine using hot glue, covering the transformer coil cores, but that is not the case. The coil winds are so high in frequency and the winding vibrates so little that you cannot fix that. So that is a negative point in my case. So you may have a chance to see this project in future when I may improve it. For now, the test, I have run it for the 15 minutes and with no load, but as the big fat resistors as the dummy load, and put my thermocouple inside it and see there is a little bit increase in the temperature. But after a few days in an exhibition, I switched it on for about 4-5 hours with no issue. So you can feel hardly any heat inside. Hope you like it. This comes really handy while testing circuits, but we cannot fix the current output, so that is a little bit, you can say, the drawback side. But as per price, this is really a good thing to make. So hope you've enjoyed it. Give it a thumbs up if you did, thumbs down for the opposite, and share it with your friends. And do not forget to subscribe this channel for getting more and more projects in electronics. So I'm Malhar, this is our Syllabus, and I'm signing off.